Hello there, it's Jay here from Jay's Vintage Junk, and today we're going to have a bit of a go at a kit build. Now, I've been after an XT-IDE actual card for a while to go in my Amstrad PC 1512. That's got the original XT 8-bit IDE hard drive implementation in it, and the hard drive is starting to fail in it. It was pretty sick when I actually got that computer, and it just about worked. It's getting to the point now where it won't even boot from the hard drive anymore. So I thought, well, like I said a while ago, I thought I want to get just a modern XT-IDE card for it. Now the problem is they're quite expensive, really, when you're on a serious budget like I am. £50 plus for an XT-IDE card, you know, quite an outlay. So I've been looking for cheaper alternatives to that. Now, one alternative is literally, and someone in my position when I've got, you know, programmers and what have you, is one way I could have gone, is just to buy the bare PCB. There's quite a few people on eBay and other places just selling a bare XT-IDE PCB, so that's it, and then basically you have to create everything else yourself. I was thinking about going that way, and then I spotted these on eBay from this company. Now I have actually bought something from this company before. This is AA Pro, and this is the company that I got my AdLib clone sound card from. I actually did a build video a couple of years ago on that. The box from it here, actually. Yeah. I don't know actually whether they still sell this anymore, but it was an AdLib clone DIY kit that they did. Like I said, I did a build of that on the channel a few years ago, and to be honest, it's pretty good. I've got it in one of my systems, and I can't actually remember which system I've got that installed in. It will eventually go in my Amstrad along with the XT-IDE, to be honest. But I spotted this kit that they did. Now this is the AA Pro 8-bit ISA bootable IDE controller, bare bones edition. I don't know if they do a fully fledged edition at the moment or not, to be honest. But basically what you've got here, I'll open the box. I am not sponsored or anything by the company, but I did rather like their sound card, so like I said, when I saw this by them, I thought, yeah, I'll give it a try. And well, what have we got in the box? We've got a basic BOM here, so got a list of all the... Oh, by the way, if you hear any meowing or anything, my cat crept into the workshop earlier and refused to leave, so my cat is currently pondering around in here, so if he makes an appearance, say hello to Mitu for me. Right, so basically what we get in the kit is we get the actual PCB. We get a backplane there. It's actually a 3D printed one, but that's fine. PCB itself looks pretty decent. White, the same as the other board that I made that they produced. Assembled in the UK. Got a fairly decent silk screen. It shows us where every component we need goes. So yeah, pretty decent really. Bit of fun on the back there. But the reason why I went with this kit, like I said, was we also get the XT-IDE BIOS. Now, I'm guessing that's on an EEPROM, so you can use the software to reconfigure the card as you need. Now, to be honest, I don't have any EEPROMs. I only have EEPROMs, which I think you could probably get to work on this, but you wouldn't be able to do that. You'd have to reprogram the chip manually every single time you wanted to change something. So that's all done for me. Like I said, I don't have to go out and get a blank EEPROM and then set all my programmer up and everything and burn that and what have you. So that's the reason I went with this kit, is because that comes included. Like I said, I don't have to either mess about getting that. And basically that's what you get in the kit. You then have to supply everything else. So it gives you a good list of exactly what you need here. You need the pin headers, 220, 2x20 pin headers. Let's have a look. If I just reach up here, you know, it's stuff that I have in stock anyway. There's our pin header. LED diode, 470 ohm, so we want one LED diode, 3 470 ohm resistors, 9 10k resistors, 1100 NF capacitors, 1 47 UF capacitor, 1 8 position double pole double throw dip switch. Now I don't think that's right actually, because if we look at the board, I think there is an error actually just on their printing here. If you look at the board there, that's an 8-way single pole single throw switch, not a double pole single throw switch. So it's just a little error on there, but that's not a problem. It's just a standard 8-point switch bank. Like I said, single pole, single throw. Each one's just its individual little switch. So there's a slight typo on the list there. That's nothing. I think we can all work out. Yeah, they put single pole, double throw. It should be single pole, single throw. That's all. We want one 32-pin socket. And then we've got two 74 LS245s, two 74 LS 373s, two 74 LS 688s, two 74 LS04s, one 74 LS32 and one 74 LS138. The BIOS, so obviously we've got that, and the instructions, which I guess are these here. I think these are the build instructions, yeah. I think are fairly self-explanatory. Mittu, what are you up to? He's found a little bit of solder on the floor and is currently chasing it around the floor. Never mind. If I can get hold of him, I might grab him and throw him out, because I don't really want him, you know, when I start soldering, he might try and jump on the soldering iron or something. This is kind of cool. Oh, by the way, if you see my fingers and stuff all over my hands, I am still tiling my bathroom at the moment, and this is the adhesive I'm using. It's a waterproof bathroom adhesive. It's very good at sticking the tiles to the wall. It's also virtually impossible to get off your fingers if you get it on your fingers, so I apologise if my fingers are looking a little bit messy in this, but there's not a lot I can do about it until I get that tiling job finished. Well, this is kind of cool. This came in the kit too. It's like 3D printed, but it's a little icy leg straightener. I've got anything I can try it with here. Have I got anything that's got some manky legs on it? Some random don't think it's very bent, but I'll grab something here just out of my random scrap box. What have we got? We've got a DRAM chip. What we do is put it in there. I think the idea is just pull it along like that. Well, now it does get caught at the end there. I think I might have to just do a little bit of trimming of the 3D-ness there. I think it's catching a little bit, but that actually works. Let me just try that again. I mean, for getting the legs straight, yeah, that actually works quite well. I think I'll just have to do a little bit of work on that side of it just to stop it doing that with the legs. It just caught with one of the legs there, but so we've got a IC there, it's all splayed out. Put it in. Me too. Slide it up. Slide it back. Yeah, actually it does a really good job straightening the legs, getting them ready for going in an IC socket. That's quite cool actually. We kind of heat shrunk this in here. Yeah, there we've got the IC we've just tried on that. That's not really for this board, but yeah, that works. Yeah, that works really well actually. That's quite kind of cool. Nice little gift in the box really. I think I'll just do a little bit of work on the edge there just so it doesn't catch if you slide it right way up and out like that, because I think that was the only issue with it. But yeah, that's cool. Right, anyway, let's get back to what we were doing. So we've got the instructions there. We've got a little sticker to go on the computer showing you how you use the dip switches there. Oh, what's that? Oh, you don't want to see that. That's my that's got my information on it. And we've got, what's this? Ugh. Presumably this is an affiliated company or something. Give them a plug. Perfect Hunt, cat toys handmade with love and passion. Perfecthunt.com. I might have to check that out, being that I've got my little furry friend in the corner over there. Right, so what we need now is we need all the other parts basically to put this thing together. Now, another reason why I went with this kit is because I'm pretty sure I've got most, if not all the other parts to build this just randomly in the workshop. I think we're going to have an appearance by a certain pussycat. Now, Mitu, what are you doing? Mitu. 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 Do you want to go out now? Do you want to go out of the workshop now? You got locked in here, didn't you? Just a minute, folks. I will just go and extract my cat from the workshop. I will be back in one sec. Right, we're now a pussycat free zone. So what I'll do actually, just show you, this is why this is a good idea, basically one of these for me. Let me see if I can remember how to release my camera by standing behind it. There we go. I'll take you off the tripod, and basically if we go over here, if you can see, I have pretty much most 7400 series ICs in stock. I've collected and hoarded spare parts for a very, very, very long time. So as you can see, I mean, when we come over, capacitors, resistors, I've probably got absolutely everything we will need to put this thing together, you know, in my boxes here. If not, I have a pile of scrap boards I can raid, see what other parts I can find. And like I said, my challenge here, what I'm setting is see if I can build pretty much this whole thing just using what I've got already in the workshop without actually going out and buying anything else. If I can do that, I can pretty much build this XT-IDE for about half the price I could go out and buy one for. So if you give me a few minutes now, I will pause the video and I will go and hunt through all my parts there now, and I will see if I can find all the bits we need to put this thing together. So back in a sec. Right, okay, we're back, and to be honest, my 10 minutes turned into quite a few days. It's a few days later now. I managed to find everything. I was absolutely determined to see if I could get everything we needed. just from what I've got. So I did have to struggle a little bit for a few items, and a few items actually surprised me on what they cost online. So I was kind of pleased that I eventually did find them in amongst my junk. But basically we've got all the passive components we need from that list I just rolled off before there. Those are all out with my drawers at the back there. We have some IC sockets. Now on the build sheet it doesn't mention IC sockets I bought from for the EEPROM. Personally, whenever I'm building something like this and it involves ICs, I always like to fit IC sockets. It just means that in the future, if you need to fault find, you know, if you need to change something, you're not having to desolder. It's not costing you a huge amount more. And to be honest, that's another good thing about this kit, because it doesn't come with anything. It's your decision. You know, you can just solder all the ICs direct to the PCB. You can buy cheapy sockets. You could go all out and buy, you know, really high-end turpin sockets. To be honest, I am using what I had in stock that fit this board. So we've got a mixture in here of some turpin, some fairly cheapy ones, but they are dual wipe. But we've got full set of sockets for the ICs there. And then let's go on to the ICs. Now, I've got them in a little anti-static box here, and we'll take static precautions, especially because in a couple of these ICs I only have the two. I had to salvage them, and they are rather pricey online. More pricey than I was expecting them to be for 7400 series logic. Now if we have a look in here, ignore my modest collection of Spectrum ULAs, but basically along here we've got all the 7400 series logic that we needed. Most of the common stuff I had in the boxes again there behind me. The only thing that was a bit of an issue to find actually was the 27 SL 573s. I couldn't find any of them in my 7400 series collection back there. I actually managed to find them on a scrap 286 motherboard that I had. Those are available. I could have ordered those online for not a huge amount of money, you know, I think 10 quid for 5 or something like that. So that, you know, they're not massively expensive, but I would have had to wait for them to wing their way from China if I want them at that kind of price. You can get them in the UK for like 5 quid each or something like that. The biggest one is these, the 27 LS 688. Those are expensive, and they're quite hard to find. Looking online, people want like 10 quid plus each for them, plus postage. I was really fortunate. I looked through all my stuff, I looked through all my parts, I looked through all my junk boards, and I couldn't find any at all. I found two on, do you know the control, the old scanning electron microscope that I turned into a desk? What make is it? It's a Hitachi, isn't it? Something like that. Yeah, it's a Hitachi. The actual original, it's an embedded computer that was in that thing. I actually kept it just for experimentation. You can't really do anything with it because all it's designed to do is take sample data and have like an image store in it and things like that. So like I say, it can't really be used for anything else, although I don't really want to destroy it because it's something quite interesting. I actually found two on them PCBs, so I desoldered them without doing any damage to the PCBs at all, and actually the silk screen what the ICs that should be there are. So I removed those from them boards. Now I know those work because them computers, they were in full working order. I had them fired up, that computer. So I managed to salvage those. Like I said, I could if I wanted to put some sockets in there and return them back to working order. But I've got those in there. Strangely enough, those are the only 7400 logic that my IC tester, my Speedmaster here, which is my programmer, and it also tests 7400 series logic, it doesn't have a profile for those. I think some of my other testers do, but to be honest, like I said, they've come off off working boards, so I can't see why they don't work. Every other one of the 7400 series logic there, like I said, most of it's new. A few of them are reclaimed. I've tested it all and it's all in full working order, so we know we've got a good complement of logic ICs there to go in the board. So I'll keep them safe like that. And said we've got the IC sockets there. We've got all the passive components, so we might as well crack on and actually start putting this thing together. Just shut my drawer so I can get a little bit more comfortable. Right, let's open this back up again. Oh, one other thing, there's one part I haven't got exactly the right part for, but I have got a workaround for it. And that is, believe it or not, that switch block that I mentioned earlier. Now, I did find on a scrap PCB a usable 8-way single pole, single throw, 8-way switch block like that. Unfortunately, I was going to start desoldering it. I was just fiddling, just making sure all the switches works and everything, and the 8-position switch there just broke off. It must have got cracked to something when it was in my box of scrap PCBs. So that's no good, and that was the only 8-position 8-way switch I can find in any of my stuff. I did, however, find a brand new old stock 10-way. So what I'm going to do is I'm just going to put some couple strips of pin header in there instead of the switch, and then I can just plug that 10-way in so we can make this video. And to be honest, I've got a few options then. I can either buy an 8-way switch or wait until I find a piece of scrap that's got one on and fit an 8-way switch there. Or, considering this is just going in my Amstrad, I don't plan on using it in other systems. It is to go in my Amstrad and stay in my Amstrad 1512. What I could always do is just use little jumper straps like they used to do in the 70s for computer board configuration, and just instead of actually having switches there, you put a link in on the pin header when the switch is closed, and you leave the link out where the switch is open, and that'll do exactly the same thing as a switch. And in fact, like I said, if you was doing this and you really was just putting this in one system, you could omit that and just literally put links in where you want it. Say you'd done it before and you was doing another system that was the same, you knew exactly what you wanted them at. I said you could omit that switch and you'll save yourself, what, £5, £4, whatever one of them switches is. And like I said, and just put link wires in where the switch is closed and leave the link wire out where the switch is open, and that'd work just as well. But like I said, I'm going to just put a couple of bits of pin header in and use that for the time being, because I've never tried configuring this before. If I really wanted, like I said, in the future I could just desolder them and even just put wire links in on this. Like I said, if it is, well, it is going to go in the Amstrad and stay in the Amstrad. So let's get putting this thing together. Right, I will actually read the instructions, because it does give you a guide on what components to put in first, so we'll follow that. So we've got it here. We've got a recommended order of assembly. We said install decoupling capacitor C2 to C12 on the rear side of the card. Right, oh, so we have components on both sides of the card. Right, okay, cool. So these are our decoupling capacitors. One there, 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 and one there. Let's start with those. Those are 100 nanofarads, which I've got in this box, in this bag. What can we'll use that there. There's a little tray. Get the IC straightener out. We may need that in a bit. That's my link for that. And we'll empty all these into there. We'll start with these 100 nanofarad decoupling capacitors. Now what I am going to do, a lot of these components are actually quite old, like these resistors here. They're probably over 30 years old. They do tend to tarnish a little bit, the legs, so everything I'm going to use, just before I use it, I'm just going to take a little bit of emery paper and just clean the legs. You see, if you was buying all your components from Maplin, not Maplin because Maplin have gone, but you know, CPC or RS or Fresnels or whoever, you won't really have to do this, but these components, like I said, have been in storage for a while, so we will just clean them before we use them. I think the best thing to do, we'll start by populating all these. Those are going to fit on quite nicely. Obviously you don't want to watch me do all this, you can just hit fast forward on the video and fast forward through me doing this, but I thought I'd do this as a full build video, you know, so you can actually see exactly how long it takes to put one of these things together. Probably going to be quite a long video, to be honest, with me doing that, but never mind, I've not done a nice long in-depth one for a while, have I? I quite like the design on the board, you know, putting a bit of fun artwork on it and what have you, rather than just being a very plain bare board. And I like the fact you can tell straight away, you know, it's a reproduction board, it's not something trying to be original. That's what I like about that ad-lib clone as well, it's not trying to be a fake ad-lib, because I've seen so many where they're trying to make them look exactly like the original ad-lib card, and then people, you know, get greedy and try and pass them off as the real thing, and it just causes problems, doesn't it? You know, if you're going to make a copy of it, make it so it's blatantly obvious that it's not the real thing. I suppose that's not really an issue with the XT-IDE because this is a fairly modern design. It doesn't take that much longer to clean your components like that. And to be honest, these components have cost me virtually nothing. It's a small price to pay just to clean them. The way I get my components is I buy job lots, basically. I keep my eye. It's harder to do nowadays, but to be honest, I don't really need to buy very many more components. I have, as you can see, quite a considerable amount. But I used to scour eBay, auctions, you name it, and look for, you know, companies that were closing or places that were clearing out, or perhaps they changed production and they no longer used a certain part, and I'd just buy up for pennies on the pound, literally, for components. But I might end up like with these, where I've got a few hundred 50 volt 100 nanofarad capacitors. And eventually, over the years, I will use them in, you know, in projects like this, in repairs, in other builds and things. So they all come in handy. It does take quite an effort to do that, rather than just buying all your components from, you know, RS or Mauser or whoever. But it is much cheaper. And it also means, if you've got, I mean, you also do need the space for it. As you can see, I've got quite a reasonable sized workshop, and at least half of it is taken up with drawers for all them components. But it does mean if you want to build something, you can usually pretty much do it straight away, because you're probably going to have the parts to do it in stock. rather than having to order all your components and wait for everything to come just to build a project. And I do have a tendency to get impatient. You know, if I've got something in my mind I want to do, I tend to want to get on and do it, not have to order parts and wait for parts. There we go. We've got 2 more, haven't we? We've got 2 more to go in. Right, last part. Well, last capacitor. We'll slot that in, push all them down, and hopefully we can flip this over and not lose any, and get that out of my way so I'm working flat on my bench. And let's see now, there we go. Right, so those all should be fairly flat. And I'm going to just add a little bit of flux. Not normally necessary, and again, if you was using components from a reputable supplier, you shouldn't have to do this, but this will just help if there is still a little bit of tarnishing on the legs. We'll have to do a lot of cleaning up of the board with all this flux, but it's probably worth it. Okay, there we go. Let's get some solder. Stand out. I've got a nice hot iron there. About 400 plus degrees, I think. It does read a little bit under that. I think when I've got it set like that, I'm about 400 on the actual iron. Okay, and let's make a start. There we go. Nearly done. Last one. Right, there we go. Let's put that down for a sec. We'll have a quick inspect from the other side, just make sure that none have gone all to one side or something. No, those are absolutely fine. I'm quite happy with those. Those are fitted on the board quite nicely. We'll take the old side cutters. Let's get them yes, I'm going to be finding them in the workshop for some time. There we go. So that's our first lot of components installed. That looks quite neat and tidy. Right, what have we got next? So we've got to install 470 ohm resistor R10 on the rear side of the card. That is that there. Now this is a fairly modern component. The leads on that are nice and shiny still, so we don't need to bother cleaning that. But what I will show you is that's a modern component, probably bought in the last year or two. That's one of my older components. Have you seen how the difference in the leg is? These are both 1/4 watt resistors. Just look at the difference in the legs though. That's another reason why I prefer, you know, if I get newer, like new old stock component stuff, this is so much better. Anyway, right, let's get this in here. So that is, where does that one go? Have a look on the back. There's only one resistor up there, and that's up there, so that's where it goes. We've got 470 there. That fits in there nicely. Yeah, I don't think we need the flux on here because this is a nice relatively new resistor. Like I said, bought it in the last couple of years anyway. I know, because it's not as good a quality as the old ones that I've got. There we go. In fact, that's just sitting up ever so slightly there, so we'll just put my thumb on it. Just reheat that side, just push it down ever so slightly. There we go, that's nice and flat now. We can snip those off. There we go. There's another one done. What have we got next? 3. Install 10k ohm resistors R1 to R9. So let's have a look where those go. Those are there. So we've got yep, they're there. We've got 1, 2, 3, 4, 5, 6, 7, 8 there, and then we have got, where are the other ones? Well, let's start with those 8 up there, shall we? R1 to R9. In fact, where are my other glasses? Because I'm struggling to see some of the print there where the that's better. R2, R1, R8, R7, R6, R5, R4, and then 10k 9. How many did we want? How many are on the list there now? Oh, 9. Right, okay, sorry. Now these we are going to have to give a little bit of a clean to, because these I know have been in my stores for a number of years. Like I said, I think these are about 30 years old. But a resistor is a resistor. The R10K, I have checked them on my analyzer, and they are in tolerance. They are all 10k, so they will work absolutely fine. Well, they will need a little bit of a clean on the legs. Like that. Set that, bend that into place. They only just fit the holes though, because like I said, modern components, the legs are so thin, and I think the holes now are being drilled with that in mind. But they do just fit through the holes. So we'll get these cleaned up. Really, it's just that bit where it's going to solder that you need to get nice and clean. because you want the solder to take. You don't want a basically, if you left that tarnish on there, yeah, you've got the acid in the flux which will eat through it, but you're more liable to get a cold solder joint, and we don't want cold solder joints. So they fit nicely actually. But I will carry on doing this. The problem with talking with you chaps when I'm doing this is I can't have any music on while I'm doing it, because it seems anything I put in the background I'm going to get a copyright strike from. Unless I put some, you know, royalty-free classic on while I do this type of stuff. There we go, that's another one. Well, I said the intention of this was to set, like, kind of show you. Oh, I'm being really pedantic now and want to know my resistors the right way around. So they all face the same way. That's 3. If this works out, I'm really tempted to get perhaps either 1 or even 2 more of these. One just to keep as a general XT-IDE card, you know, for when I'm messing about with various systems. And another one possibly to go in my IBM 5150. That's something I've never actually shown on. I think I might have like given tantalising little glimpses of it, but I've never actually shown it proper in the channel, and it's probably not been switched on since sometime in the 90s. But yeah, I have. I don't even remember what cards it's got in it, to be honest. But I do have up in my office a original IBM 5150. Unfortunately, the one thing I don't have for it is an original keyboard, either a Model F or a Model M. I used to have a Model M, but I don't know what happened to it. I'm sure I had it in storage somewhere and it's just vanished, it's just disappeared. That would work with that computer. I do have another Model M that's for a later 80 only system, but the one that I had was a really nice Model M keyboard that actually was, it was the, where was it made? Was it made in Scotland or Ireland? It's one particular Model M keyboard, and it was actual auto switching between XT and AT. And most Model M's were either XT or AT, but there was this one particular model, like I said, I think it was either made in Ireland or Scotland, and it auto switched. And I did used to have one, and I don't know what the hell's happened to it. And I can't afford to replace it. Buy another Model F or Model M keyboard because they are stupidly expensive nowadays. But apart from that, it is complete. I do have the correct monitor for it. I think it's got the right disk drives in it. I don't know what expansions it's got in it. I don't know what graphics card it's got in it. I think it's just a standard MDA. But I bought that in the 90s at a car boot sale for £10. And if when I do eventually get to actually getting that computer up into a nice working displayable computer, it would be quite nice to have an XT-IDE in that. Just to make it, you know, that little bit so I can actually boot things up more than just running everything off floppy like it would have originally. That's another one there. Two more down there, one more up there, and then we can start soldering them in. There's another one here. Oops. And that. I've got lots of projects in the offing at the moment, but I'm really reluctant to start things. Like I said, with trying to move house as well, I don't want any more I've got lots of projects that are part done or are waiting for inspiration or what have you, waiting for me to get back to them. I don't want to start. I'm doing this. This is we're talking while I work. I've not cleaned the legs yet. So I don't really want to start any more major, you know, rebuilding of computers or anything at the moment until I know what's happening with moving. They say it's one of the most stressful things you can do in your life, and I think that's pretty true, to be honest. Especially when you've got, you know, underlying factors like having to sell 2 properties and people not wanting to move that you need to move and things. It makes things a lot harder and a lot more stressful, especially when you don't exactly live a very standard run-of-the-mill 9-to-5 kind of lifestyle. Oops. Pulled on a little bit too high then and bent it, but it should still go in. Right, give that a clean there. I think this is the last of these 10Ks to go in. There we go. And that is, where did I see that one? 10K there. So the other 2 resistors are the other 2 470 ohms, so we'll probably put them in next, to be honest. Right, let me get you zoomed down a little bit at least so you can see a bit more of my soldering. Not that my soldering skills are exactly fantastic, but you can watch. Again, because we're using those older components, I'm going to put a little bit of flux on each point. I mean, we do have flux in the solder as well, but we want nice clean joints here. We don't want any sloppy joints. I'll give the iron a good clean. You've noticed I'm using actually quite a large bit on here, but it's got a very flat end on it, and it's ideal for basically soldering components in like this. We go in. You get a good thermal transfer with it. That's that side done. We may go back in there and touch them up. Do this one. Oops, you didn't see that. Sorry about that, folks. We'll see if we can get this on shot. Right, there we go. Let's cut those legs off and we can see how that's looking. There we go, the last lot to take off. And there we go. Get those off there. Come on, off you come. And that's looking pretty good. That's that there. That's all the resistors down there. That's our resistor there. Let's see what it's telling us next. Install, right, yeah, install the other 2 470 ohm resistors. Let's get them on. Where's the other one gone? Come on, out you come. So let's get those on the board. We've got one there. I've got another one there. Again, like I said, these are new components really. Like I said, they've not been in my stores for decades, so these don't have any tarnish on them. They'll be fine just to use. Let's try and get that. Come on, in you go. They're not, these modern ones, they're just not as good as the old though, I will say that. Right, those are flat down like that. Let's get those soldered in place. Get you over a little bit so you can see what I'm doing. There we go. Right. You see these just solder just fine because they're nice and clean. There we go. Get them snipped off. And I think that's all our resistors done now. So what's it telling us to do next? Right, install the 32-pin IC socket U8. So we're putting the big socket in there for the EEPROM. So I've got a box of assorted sockets here. Like I said, they're not all one type, unfortunately, because it's what I was using out of my stocks. But what it does mean, we do have a rather nice turn pin socket for the EEPROM. So that goes in like that. This is fairly, again, it's there's no tarnish on this. It is fairly newish. I'll put something under there. Basically, I don't want the board to rock like that while I tack it in place. That's sitting nice and flat there. So we'll tack two legs and then we can go in and solder it. So if I go in and I just tack that leg there, I tack that leg there, I can pick it up. I can just make sure that that is indeed nice and flat, which it is, and put it down, and we can just solder that in place now. We could clean this flux off as we go, but to be honest, I think what I'm going to do is I'm going to assemble most of it and then I'll go through and clean all the flux off the board. Right, there, okay, there we go, that's in. That was fairly painless. Right, what have we got to go next? Let's have a look at the instructions again. So we've done that, Install IC, right, it's asking us to install the ICs. I'm not going to install the 7400 straight onto the board. Like I say, I'm going to put sockets in, so that's what we'll do next. We're going to fit all the IC sockets here. So in fact what we will do, I will get my PCB cleaner. So I want this to be quite a nice neat installation, to be honest. I'm going a little bit over over what I would normally do for some reason. Right, where's my scrubbing brush? We'll give them a bit of a clean off now. And then we're not trapping that flux underneath the ICs where it's going to look a bit of a mess. There we go. Don't have to be perfect, but let's grab a Q-tip and just give that a quick wipe down. Come on, out you come. There we go. There we go, that's neater, isn't it? That's nicer. Little bit of professionalism there. There we go. It didn't take very long to do, and it just makes it, the end result's just going to look that little bit nicer, isn't it? Right, let's get some IC sockets on there. Now, unfortunately, again, we've got a mix of rather nice turn pin and I mean the dual white, but the cheapy dual white ones. So let's get them in first. We've got 4 of them. Oh, hang on, that's not for there, that's for there. That's 1. Let me find a little screwdriver or something, because I don't want to bend the pins getting these apart. Not pointy enough. Need something pointy, just 1 second. Aha. There we go. There we go. That goes that way up. They do have a little divot on them which matches up with the divot on the ICs, so make sure you try and get them in the right way around. We'll try and get this down. In fact, what we could do, right, put that flat on there and then turn it over. I can then slide the piece of paper out, and none of my ICs have dropped out. There we go. And because we've already done the IC on that side there, that's kind of holding it flat. Oh. There it is. But what we'll do, like we did on the other one, we'll solder 1 corner there, we'll solder 1 corner there, solder 1 corner there, we'll solder a corner there, corner there, corner there, 1 there, 1 there, like that. Now I pick that up, I can check them, I can make sure they're all nice and flat. Like I've just noticed, that's just sitting up ever so slightly there, so we can just heat that ever so slightly. Just make sure that sits flat down. I think that one's okay, that one's okay, that one's okay. Right, I'm happy with them now. Let's solder them into place. Just break off another piece of solder. There we are, lovely. Yeah, I'll swap over to a new piece of solder before I burn my fingers. Right. There we go. Okay. Slightly awkward soldering around those capacitors, but you couldn't really do it the other way around, or else you'd never be able to solder the capacitors in. So it really, you do have to do this in an order. So if you was to put the IC sockets in first, you're going to really struggle to then solder those capacitors in. So it is a good idea to follow the actual assembly procedure that they've outlined there. Right, I'm quite happy with those. So we've got those IC sockets in. Again, like I said, if you was doing it cheaper, if you was if you wanted to, you could just put the 7400 series straight onto the board there. I've never liked doing that when I'm building stuff. I said for the few pence, well, probably a couple of pound nowadays it would cost you for the sockets. I'd rather have that peace of mind of having the sockets there personally. It does. I will say though, it does make the board slightly thicker. It's not going to be an issue where I'm using it, but that's obviously you would have to bear in mind that it does actually make the board that little bit thicker, depending on obviously depending on what you've got near it, would depend whether you want to do it like that. I've got a bent pin here. Just try and get that straight. Yeah, there we go, that's gone in. Sadly, one issue I am going to have is these are really nice top quality turn pin sockets, and a couple of the ICs going in them are salvaged, which means they've got solder on the legs and they don't like going in turn pin sockets, so we're going to have to perhaps do a little bit of clean up on the legs to make sure that they are going to go in properly, but that's nothing major. Right, okay, so we've got all those in. I'll try that little trick again. I'll put my card on it, spin it over, slide that out, and again I'll just solder first one corner on each one. Give that a quick clean, quick re-tin, and we'll just solder that pin, that pin, that pin, that pin, that one, 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 and that one. And again, we'll just do the same again. We'll pick it up, we'll just make sure that those are all nice and flat, and they are. I'm quite happy with that. And then we can solder these into position. Yeah, you can still see what I'm doing. People make videos like this. It was an ASMR, where you're just watching people do stuff, so treat it like that if you want. Right. I mean, this is a fairly simple board to solder together. Just imagine back in the 70s, when the first computer kits were coming out, and even your CPU was just based on 7400 logic in some of them earlier computers, some of the earlier kit computers. So imagine soldering like this, but hundreds and hundreds of IC sockets rather than just like half a dozen or so. It kind of and you didn't have like modern temperature controlled soldering irons like this really. The most you'd have had is something like a Weller Magnastat, and that's only if you had the money or you'd borrowed one from work or something. It's amazing that some people got those early homebrew computers actually working, if you consider the equipment that they actually built them with. In fact, there's a channel that I really enjoy watching. What's it called now? Tech Time Traveller. I think he's in Canada, and he's really into like the early like 1970s homebrew computers and that computer scene. It's well out of my price range, but some of the stuff that he gets that has been homebrewed by people back in the 70s, it's fascinating. What people actually put together in their basements and in their spare rooms, and actually got working and actually got viable computers out of really. So a little bit of kit assembly like this really is nothing compared with what those chaps did. Nearly there. Right, there we go. I don't think I've missed anything there. Put that back down for a second. Right, so we've got all our IC sockets in. We've got that to go. We've got a... Right, that there I don't actually think I'm going to bother using, to be honest. That is for 5 volts output. Which I'm not going to... I suppose I could put 2 pins on there just for the sake of it, but I don't honestly think I'm going to use that. Right, let's get a couple of these pins cut off. We want... In fact, let's have a look at the instructions just to see what that tells us. But I think this is what we need to do next anyway. Right, so we've got... alright, install LED D1. Let's put that LED in. Yeah, there it is. We want the flat side, that's the flat side, that way on, like that. So we'll put him in the board. Have to bend his legs out slightly. And again, this is a fairly new component. I remember when I bought these, it was only like last year or the year before, so I think these are okay to solder straight in. Yeah, that's fine. Still got nice shiny legs. It's them resistors and occasionally those capacitors, because I know they are really quite old, but they are still perfect. There's absolutely nothing wrong with them. There's absolutely no reason not to use them. Right, so we've got the LED in situ there. What's it telling us next? Install dip switch SW1, which is that's the one thing that we don't have the correct one of. So we have a 10 weight. So what we're going to do, and it is brand new from Radio Spares. Again, this is probably quite an old component actually. This is the old RS packaging. I don't know if there is actually a date on it or anything, but it's probably quite old. It's probably at least 20 years old. But it will work perfectly well. So what I'm going to do, I'm not going to fit that straight in. I'll just have a look on here. Is it that one? That's not the right one. Just bear with me a second, folks. Aha, what have we got in there? That'll do. What we've got, I've got some pin header here. That's the only piece I've got left, I think. Thought I had more of this, but obviously I've not. Come out. There we go. So basically you can use this to make IC sockets and things. You just cut it to length. So what I'm going to do, I'm going to cut 2 pieces of this. That's one. Where did that fly to? There it is. Alright, so those fit in. Where's that one not going in there? I've got a little bit of solder in the hole, damn. There we go, it's gone in now. Right, so basically we're putting those in there. If we take the switch now, I'm going to push the switch in like it was an IC going in an IC socket. Like that. If you can see the last 2, which are 9 and 0, which we don't use because we're using it's using it as an 8-way switch, just stick over the edge like that. It's not. I think it's not going to actually affect. I think it's still going to be able to go in like that, and we'll just use that for initial testing. And I'll either get the correct one, although that doesn't mean me buying one or searching out one off a piece of scrap. Or I could just hardwire it if we do just decide to definitely leave this in the Amstrad, like I said, which is the plan. But that will keep them pin headers straight now, putting that in there. So again, we can do it exactly like we did last time. We'll solder that side there. We'll solder that one there. We'll just make sure that's absolutely nice and flat. Yeah, I'm happy with that. Right, there we go, that's in. So that's our switch bank. So it works exactly the same, it's just we have to ignore them last 2 there. That's the only difference. And I kind of, like I say, if I want, I can pull that out, put the right one in, or just put links in between to hardwire the card. Right, so I guess we've put these last few little bits in here now. So we want a 40 pin there for the IDE. So we want to cut it there. Out you come. Like that. Now what I'm wondering whether I should do is remove, there's one pin on IDE which isn't used, and a lot of IDE cables, especially the newer ones, actually have that pin blanked out. Now let me just have a look in my IDE, have I still got that on? I'm not touching IC sockets, just 1 second with them folks. Let me just have a look. I've got an IDE cable around here so I can show you what I'm talking about. Oh, and I bet you everyone I pick up now, no, there's one. In fact, that's what I used to do all the time. There we go. If we look on some IDE cables, one of the pins there, let me get you in shot, is actually blanked out. It's not used. if you've got, basically, it doesn't matter if all your cables are the older style cables that don't have that pin blanked out, just leave it as it is. What I actually used to do back in the day, in fact I've even done it on this one, is take a drill and actually drill it out on these so I could just use it universally, because a lot of the things I had didn't have it off. A lot of the newer cables I had did, so that's what I used to do. But I think what I'll do is I'll just pick the appropriate pin on here, which is, let me get that lined up like that. That pin there. And we'll just pull it out of the I've got it raised up slightly. I think we can get hold of it and we can just actually pull it out. There we go. Oh, it broke off, whatever, it's gone. I wonder if I can pull the remains out from that way. Yeah, there we go. Just get that out like that. There we go. So that is basically what it means, is we can we plug that on there now. Even if we've got one of the even if we've got one of the cables that's got that blank in it, we can still use it, because that pin's not used in any way. It's just basically like a key, so it doesn't now matter whether we, like I said, if we pick up one of the newer cables that has that key on it, it won't matter. So we'll put that in there. Unfortunately, with everything else, this is going to be slightly tricky. I'm going to have to hold the board down while I just tack the first points. I mean, I suppose I could take my switch back off, but meh. That's that one soldered. Let's solder there. Just make sure that that's square. Yeah, that's square. That's nice and flat. We'll solder that in place now. Because these pins are a bit bigger, they do take a tiny bit more effort to actually get the solder to flow, but they're going in nicely. There we go. Have I got enough solder to finish the soldering without having to get some more out? Right, there we go. So that's soldered in place. So what have we got left now? Oh, well, all we've got really are those two left to go. Oh, and the capacitor there, and I don't remember whether I've whether I've got one of them out. I don't think I have. 47 UF. I know I've got some of those behind me there, so I can grab one. Let's put these two pins in here now, and then I will go and grab a 47 UF. I very much doubt I will ever use, I might actually use the hard drive lead there, but I very much doubt I will use the 5 volts there. Although I suppose it could be handy having it on. Let's see if we can keep them in place while we bend this, we'll get this over. There we go. Again, we'll just tack them in place and then we can make sure that they're straight. That's 1, 2. Solder them and then we can always. There we go. Let's make sure those are. Oh, just heat that back up. There we go, that's straight now. Yeah, and the other one's perfect anyway. Lovely. Right, I think that's... oh, capacitor. Let me find that capacitor now. 47 UF we want, don't we? It's 47 to 47 UF. It'll have to be a salvaged one, but I don't think that'll matter. Oh, I've got a Rubicon there, that's a nice one. That'll do fine. And these have just been pulled off modern PCBs before I've binned them, basically, because why buy new ones when it's just like a basic capacitor like this. Let's clean the legs off a bit. Make sure we get that the right way around. There we go. We'll sit that in like that. This is the last component to be soldered in place, and I've got these two tiny little pieces of solder, and I really don't want to break another piece off. So let's see if I can do this without burning my fingers. Yeah. Oh yeah, just. Snip them. There we go. Lovely. So that's it. Basically all we need to do now is stick all our... well, in fact we need to put the... put the plate on. Come with screws? Will it just kind of like self-tapper in? I presume it must do. Can't see any screws in there. Let's try... fitting that. Try a different screwdriver because that's not working very well. I might have to come up with some different screws for this because I don't know whether these are going to work very well. See them a little bit on the large side to be honest, but I'll persevere for a minute. Let's see what we can do. You fit that properly. I don't believe getting this in is the hardest part. Right, let's try that again. Ah, right, okay, that's going in now. Right, they work, but they're a little on the long side. Let me put it together with them, but I might look at perhaps something different there. They do seem a little bit on the long side. screw in. The other one did. Problem is it's a machine screw, trying to self-tap into plastic, which is never really ideal. There, I think I've got it going. There we go, it's gone now. I mean, it does actually hold in there quite securely. The point where that's bending that now. There we go. It's not terrible. Better than having no back, no support at all, I suppose. I do keep wondering. I've got loads of back planes. Whether I could perhaps either spot weld or even make little tabs onto a back plane and just make some that I could actually use. So I've got a proper metal back plane again. Right. Let's give that board a quick clean before we go any further. Where's my PCB cleaner gone now? It's getting very empty, that can now. Right, let's give this a... oops. I'm not trying to burn the desk down with the soldering iron. Give that a really quick... clean over now. There we go. Where's that Q-tip? There he is. And you can shine and just get the last of that off. There we go. There we go. Get that bit from around there. There, we've not gone mad at the cleaning, but at least it looks a little bit better than it did. That looks nice and clean on that side there. Right, let's get some chips in here. Let's get the old anti-static back on. Okay, that's my anti-static back on. In fact, actually, I can switch the soldering iron off now. There we go, that's the iron off. Let's get the 7400 logic in here first. Now, I have pre-tested, like I said, all this apart from those two, but they did come out of a working board. But in fact, let me put that iron back on. No, I don't want to switch it back off yet, just in case we need to dress some of them legs up a little bit. Right, let's start with the small stuff, shall we? So we've got a 74 LS004. That goes there. Make sure we get it the right way around. That's the first one in. Then we have got a, oh, that's another, oh, do we need two of them? Oh, sorry, we need two of them. So there's another 74 LS04. Okay, what have we got next? We've got a 74 LS32, and that goes there like that. Then we've got a 74 LS 138. That's an old one as well. Not that it matters, if it's the right component, it's the right component. It doesn't really matter what date it was made in. In fact, what we need there is we need the chip leg straightener that we got free. We'll just run that. Like I said, I'm not going to run right to the end because I've not had a chance to just fiddle that off at the end there, but we'll just run that up to the end like that. run it back down. Let's try that in there now. There we go, right in. Right, let's put the 74 LS245s in. So 74 LS245 there. Fortunately that is a new one. That goes straight in. So is that one. That's another 74 LS245. That goes in there. Right, now we want the 573s. Again, these were salvaged off an old 286 motherboard. Fortunately they were socketed, so I didn't have to desolder them or anything. There we go. One more of those to go in. Again, let me just use the chip straightener. Just push it in there, push that along, and pull it back that way. I just put it in that way and try that. I will definitely, like I said, get a scalpel blade on that and just tidy that end up a bit so you can slide them right out. Because apart from that, that's quite a nice, useful little leg straightener. Not bad for a freebie that come with the kit. And there we go, that goes straight in now. Right, these are the two that I'm a little bit worried about, because these are bloody expensive. I was a bit shocked how expensive these are, to be honest. It's well over £10 guaranteed in the UK each. Well, that one went in alright. Let's try this one. Let me just try straightening the legs on that before I try putting it in again. Okay, so these have come off a board. I did have to desolder these. It's not got the longest legs on it, but fortunately with a turn pin you can usually get away with it. There can just be a little bit of a mare to actually get in the socket. Is that going to go? Are you alright? There we go, it's gone. Lovely, that's in. Right, last but by no means least, we have got the supplied XT-IDE BIOS ROM. Let's get in there. Well, I think that could do with definitely getting the legs straightened a little bit. I'll put that in. I won't try and pull it all out, again that's a bit, yeah, it's going to need a little bit of fettling, that straightener, just to get it right, but it seems to work. And we'll go that way up, drop that in there. There we are, push him home, and that's it, built, and that looks pretty good, to be honest. Right, I've been talking for quite some time now. I've just noticed my battery is about to fail on the camera, So what I will do, I will just go and make myself a coffee, have a quick coffee, and then we'll have a look at actually putting this in a computer and seeing what it does. I'm actually going to use my Amstrad 2286 for testing, for the simple fact it's on my bench. My 1512 is actually a bit buried away at the moment, and I'd have to sort a different screen out and things for it. So we'll use this for initial testing, but it'll work. Just if it works in that, it's going to work in the 1512 anyway. Right, so I will go and have a brew, and we'll be back in a sec. Right, okay, we're back. Actually, quite some time has passed. And as you can see, my workbench is a complete mess. There's things everywhere. We've got a computer which is not the computer I said I'd be trying to install this thing in here. And the thing is, I cannot get this card to work. I've been trying for the best part of 4 days, you know, when I've had some spare playing about time, to try and actually get this thing up and running, and so far I've been unsuccessful. The reason I've got it in this computer here, this is a digital DEC PC 433, so it's a 486 SX33. The simple reason I'm using this is, one, it's not an Amstrad. And Amstrads are fickle machines. They tended to do things a little bit different to other PC manufacturers, and because I was having problems, I thought, right, I'll get something which I know is a little bit more standard out to fault find on. But I'm still having major issues with this. Essentially what's happening, let me get you up on the screen. There you go, you can see my screen there, and if I power up the digital here now, if I can find out where the power button on it is, right there, that's powered up. Now I've got the XT-IDE installed in here, and I've got an old 1GB IDE hard drive connected to it, which I know works, and I know it's set as a master. The computer boots up fine with the XT-IDE card installed. If you look here, I think that was from me messing about, but basically it cannot detect, it basically cannot detect any hard drives plugged into it. I've done a little bit of testing around up to now. I'm pretty sure, for one thing, it's not the computer. I'm pretty sure it's not the hard drive. I've actually tried probably 5 hard drives on the, well, a couple of compact flash cards in an adapter like that, and a few hard drives on this so far. And like I said, I just cannot get past that point we're at now. As you can see, I can actually get the ROM BIOS to XT-IDE BIOS to boot up like that, but that's it. One thing I will say, these AA Pro cards, they're not exactly the same as other XT-IDE cards that are out there in the wild. I have only just recently, or since I've been having issues with that, found that out. It's basically to do with the way that the XT-IDE BIOS there works. When AA Pro came up with their version of it, they've implemented the BIOS, the ROM, ever so slightly different. It's actually a different ROM to than what most XT-IDEs use. That shouldn't really be an issue. As far as I'm aware, sorry about that, folks. My my battery went flat. I really do need to get some new ones of these. These are starting to get to a problem. Yeah, as I was saying, the way that they actually implemented the XT-IDE BIOS, like I said, they use a different actual EEPROM than most. Like I said, it's not a major issue, but it's going to make actually try to fault find on this a little bit different than, like I said, if it was a bog standard XT-IDE, because there's lots and lots of information out there. There's lots of circuit diagrams, lots of schematics, What I have already done, I have done a little bit of filming on this already, because, spoiler alert, there's going to be a part 2 on this. And this video is already massively long, so there's definitely going to be a part 2 on this. But yeah, basically, I've already tested all the ICs on here and confirmed that they all definitely work. I've done some basic checks on the board and things like that up to now, and you know, I can't find a fault yet, so like I said, that's why this is definitely going to be a two-parter. So that's essentially where we are now. I am going to leave this video here for now on a bit of a cliffhanger, whether can we get this board to work or not, and there'll be a part 2 coming up when we find out what the issue with this board is, or we'll perhaps go a different way, perhaps get another board which is a complete, you know, definitely exactly like all the other XT-IDEs. Although I think this is kind of nice. As far as I can see, you don't actually use the XT-IDE config software with this. It basically it's plug and play. You've got a little bit of configuration to do with your like oddballs like the Amstrad and some Olivettis and things. But apart from that, it should, if this board is working right, you should be able to basically plug it into a system, hook a hard drive up to it, and it just work. Without, like I said, the XT-IDE configs. As far as I can see, that is not implemented, like I said, with this slight different version. Like it's the same idea as XT-IDE. It basically works in the same way, but like I said, the guys at AAA Pro, whoever come up with this, have kind of come up with their own adaptation of it. So it's not a major issue. I do have the circuit diagram as well that I found on their website, so I can go into that. But I think, like I said, in the next video I'm going to be pulling the scope out, and we will get to the bottom of this. So I will say, I hope you enjoyed watching that video. I hope you enjoyed watching me build this thing. So I will say, until part 2, thanks for watching and goodbye.